Hi, in this video lecture, we're going to learn a HackerRank problem titled Delete a Node, which is in the data structure sections and subsection of linked list. Let's quickly read the question and try to understand what we need to do in this. The problem statement says that delete the node at a given position in linked list and return a reference to the head node. The head is at position 0. The list may be empty after you delete the node. In that case, return a null value. They're given some sample example out here with 4 nodes, and the first node is at position 0. This is position 1, 2, and 3. And we need to delete a node at position 2. The node at the position 2 in this particular case is 2, which we need to delete. After we delete this element, the list should look like this: 0, 1, and 3, because the element at position 2 will be deleted. In this task, we need to write the code for a function called as delete node, which has 2 parameters. The first parameter will be a pointer to a single linked list node called as list, and the second parameter will be an integer type called as position that will specify the position of the node to remove. And we need to also return a pointer to the single linked list node, which has the reference to the head of the modified list. They also specified input format where they say that the first line of input contains an integer n, the number of elements in the linked list. Then each of the next n lines contains an integer, the node values in order. When I say in order, that is one after the other. It will have the same order in which you have inserted. And the last line contains an integer called as position, the position of the node to delete. They also specified the constraints. The n will be within 1000 and each element of that will be within 1000. For example, here, first they specified 8, which is the value of n. After that, the next 8 entries will be the values of a linked list, like 26, 2, 19, 7, 4, 15, and 9. After that, the last line will specify the position of the node to be deleted. So once you have entered these 8 elements, the list looks like this, where you have this 20, 6, 2, 19, 7, 4, 15, and 9. But after deleting the element at position 3, remember, head is at position 0. Okay, so we can say the first node, which is 20, is it at position 0, 6 is at position 1, 2 is at position 2, and 19 is at position 3. So after deleting the element at position 3, the list should look like this, wherein we have 26, 2. After 2, we need to point to 7, then 4, 5, 19. This 19 should be deleted. Okay, so here the code for inserting a nodes, everything is already written. So you don't need to bother about reading the value of n as well as reading the elements and everything. So you just need to write the code for delete node. Now, first I'll be writing this code into another platform called as Python Tutor, because I can show you visually how it works. Then I'll try to copy paste that particular code in this particular platform. So here is the code out here. Here I've already written the code for the insert node at tail, which I've already created a separate video out there. And then here I'll only be writing the code for deleting a node. Now, whenever you want to delete a node, there are 2 cases. One, if the position is 0, in that case, the head node gets modified, wherein the head pointer should point to the second node. And the other cases, wherever the position is other than 0, wherein in between intermediate pointers gets modified. So first I'd like to take care of the first condition, that is, if position is equal to 0, the special case wherein the head pointer gets modified. So in this particular case, what I'll try to do is I will try to create a pointer which is going to point to the head node. And yes, this will be specified as list. If you want, you can rename this and refer to as head, which is perfectly possible, right? Now here I try to create a pointer out here, and this I'll say it's a pointer to delete node. The pointer which is going to point to a node which would be deleted. I'll make it point to head. After that, I'll try to update the head pointer point to the text node. I'll say head equal to head of next. Now, after this statement, the head pointer is pointing to the second node, and you have this pointer to delete pointing to the first node. And I need to release the memory, because once you delete the node, we can release the memory. So we can use free if you're using C. We can use delete if you're using C++. I'll say pointer to delete, done. So if you want, you can just try to return the updated value of head, done. But in case if the position is non-zero, then I need to reach out to the node which needs to be deleted, right? Like for example, if position is 3, so in this particular case, if my position is 3 out here, I need to reach out to this. But also remember that we are working with a single linked list. So once you reach to 19, we cannot go backward. That's one thing. And the next thing is when you want to delete 19, the link of 2 should point to 7, right? Now, so for this, what I need to do it is I'll be basically using 2 pointers. One pointer which will be pointing to the node, which is to begin with, it's going to point at the head, and there'll be one more pointer which will just be one step behind this. Now we're going to check out, okay, fine, is this the node to be deleted? No, okay, because we are not reached to the position out there. So I'll try to bring in one more pointer and I'll try to call that as previous, and I'll try to jump here. Okay, I've jumped once here. Then again, okay, since you have only jumped once, you're not reached to the correct position as of now. So I'll try to bring this here, and after that again I'll try to jump this here. So I've jumped 2 times out here. Let me change the color, and then again I'll try to bring in here, and then I'll try to jump here once more. Now you have jumped 3 times. Okay, so here this point is pointing to the node to be deleted, and there's a pointer which is just one step behind. So once you jump 3 times, 1, 2, 3 times, that is position number of times, we need to stop. And this is the node to be deleted whose memory should be released, and we need to make the link of this one point to this. And I'll try to call this pointer which is just one behind the pointer to delete. I'll call it as previous. Okay, so let me just go and write the code for that. Let me try to erase this portion. So I require 2 pointers. One pointer which will be pointing to the previous, pointer to previous, which I can initially set it to head pointer, and also be pointing to the delete node, which will be pointing to the head. Now, if you want to say that previous should be one behind the head, there is no node behind the head, so I can just set it as null. I need to run a loop position number of times. So I can just say I equal to 0, I less than position. This will run position number of times. Yes, if you want to also take care of the situation wherein the position whatever is specified could exceed the number of nodes in that particular case, so we can write the condition out here and pointer to delete not equal to null. So make sure that you try to run position number of times, but if you reach the end of the linked list, okay, before that, then also you need to stop. Okay, and I will be updated. And what will I do? I need to update this pointer to delete, but before I can update this pointer to delete, we can point to the next node, because once I go to the next node, I cannot come backward. So I will try to say ptr previous equal to ptr delete. So I'll try to make the previous pointer point to the current node, or also called as pointer to delete. And after that, I'll update this particular one. So once, okay, you have traversed for position number of times, then you have reached the point where we need to delete it. Okay, and since we are also taking care of this one, wherein there's also possibility that the position specified could be much more than the number of nodes what you have in the list. In that case, you would have come out of the loop when the pointer is null. So if the pointer is the pointer to delete has reached null, it means that the position is invalid position. So I can just check out if pointer to delete is not equal to null, then the position specified was valid position, which is within the valid values of the number of nodes what we had in the linked list. So in that case, I need to make the pointer to previous of next, point to pointer to delete of next, right? So example here, so we had pointer to delete pointing to 19, pointer to previous pointing to 2. we need to make the link of 2, or you can say the next portion of 2 point to the link which is presently pointed by 19. So wherever 19's of link is pointing, okay, 2's link should point to this. So 2 should now point to 7. So once you do this, I can release the memory free ptr delete. That's it. My task is done. Okay. So irrespective of you have deleted the node or not deleted the node, I'd like to return the updated value of head out here. Fine. So this is the code for deleting a node, but I'd like to visualize this. Okay. So I'll just click on visualize execution. So execution starts, but I don't want to do step-by-step execution for the insert node at the tail. Okay. So I'll just click here stating that the next step I'd like to jump to this one. I'll click on the next. So you can just see the linked list is created with all these values, 20 being the first node, then 6, then 2, then 19, then 7, 4, 15, 9. Okay, these are the linked list. Okay, nice visualization out here. Now, the position is also specified is 3 out here. So I'll just jump inside the code out here. So here is a position 0. No, position is not 0. Right? So I'll come to the statement outside the if, which is line number 35. I'll try to bring in 2 pointers. Pointer to previous will be pointing to null. Pointer to delete will point to the first node, which is the head node, which is 20. Now I need to traverse 3 times. So first time you can just see pointer to previous will also point to the first node, and then delete node jumps to second one. So now pointer to previous points to second node, and pointer to delete points to the third node out here, right? So again, you can just observe pointer to previous comes to this 2, and then pointer to delete is out here. So here, okay, you can just observe I have traversed 3 number of times, like 0, 1, and 2. Okay, 3 iterations. Now I have a pointer to previous, which is pointing to a node whose data part is 2. And I also have another pointer to delete, which is pointing to a node whose data part is 19. So when I come out of this loop out here, I'm going to check if the pointer to delete is null. No, it is not null. Okay, so here in this case, I'll say ptr delete of next, right? So I will take up ptr delete of next, which is this portion, and I'll try to put it into this portion. So after setting this one, the link of the node 2 will point to 7. Please do observe this. Link of 2 will point to 7, right? Okay, you might say that even this is also pointing to this. Yes, but I will be releasing this memory. I'll be deleting this memory. Once I delete this memory, you can just observe 19 is out. So we do have 20, 6, 2, 7, right? And then the remaining 4, 15, 9. Okay, so this was the code what we need to write. Now I'll try to take this particular code and then try to submit this in the HackerRank. Take this code, the function. Okay, since we already changed the name of the parameter to head, I'll try to take this line also, and I'll try to place it here. Right? Don't try to change the name of the function, because the name of the function is important, because that is the name through which it is being called out here, delete node. And we cannot even change the name of the structure out here, single linked list node. So let me try to run this particular code. The sample test case is passed, and then I'm submitting it. All the test cases are passed. So I hope you guys have understood each and every line of this. I'll be sharing you the link of this particular platform, this Python tutor one. Okay, you can just click on the link and you'll have access to this particular code. Right? Thank you.